I'll read through the next set of problems, and we are going to provide the solution shortly. So let's quickly go through the solutions. So the first question is that a ball rolls down a slope and travels a distance d given by t squared minus 0.75 t, where t is time in seconds. Find t when the distance traveled by the ball is 11.25 feet. So this means that we need to solve t when d is 11.25. So this is as good as replacing d for 11.25 and then solving for the quadratic in t. So 11.25 which is the same as t squared minus 0.75 t minus 11.25 equals to 0. Then using quadratic formula, t will be 0.75 plus or minus square root of minus 0.75 squared minus 4 times 1 times minus 0.11.25 divided by 2 by 1. So we have t equals to 0.75 plus or minus square root of minus 0.75 squared gives 0.5625 minus 4 by minus 11.25 gives us a positive value, which is 45 divided by 2. Then 45 plus 0.5625 t equals to 0.75 plus or minus square root of 45.5625 divided by 2, and the square root of that value is 6.75. We are dividing this by 2. So t will be 0.75 plus 6.25 divided by 2, or t will be 0.75 minus 6.75 divided by 2. So the first one will be 0.75 minus or plus 6.25. If I divide by 2, I get 3. So 0.75. So this is, remember this is 75 plus 6.75 divided by 2. I get t equals to 3.75 seconds, or this will be t equals to 0.75 minus 6.75 divided by 2. So this will be -3. This one we ignore because we don't expect time to be negative. Time is a scalar quantity, can only be positive. So therefore, it takes 3.75 seconds to travel a distance of 11.25 feet. Our next problem was A pole has to be erected at a point on the boundary of a circular ground of diameter 20 meters in such a way that the difference of its distances from two diametrically opposite fixed gates P and Q on the boundary is 4 meters. Is it possible to do so? And if the answer is yes, what is the distance from the two gates should the pole be erected? So let's check how to work out this. So let's say, let the distance between the pole and the gate P be X. So this means the distance between the pole and the gate Q is X minus 4 meters. So we can represent this on a diagram. So if this is the circular boundary, then let the pole be at this point here. Let's have P at this point here. And let's have Q at this point here. So if I join this, and I join this, I can join this PQ. So this is what you're calling X, the distance between the pole and gate P. So the distance between the pole and gate Q is X minus 4. So from this figure, so remember the distance between, so the question was a pole has to be erected at a point on the boundary of a circular ground of diameter 20 meters in such a way that the difference between its distances from two diametrically opposite gates P and Q, the boundary is 4. So remember, this P and Q should be on the diameter, should be the diameter of the circular ground. So then so this PQ, so my figure is not necessarily done to scale, but then this should be, if this is the center, then this is a diameter from the information given in the question. So the distance here, this is 20 meters. So if this is 20 meters, then you expect this to be 90 degrees. So by Pythagoras theorem, we have x squared plus x minus 4 squared should give us 20 squared, because that's a right angle triangle. So x squared plus x squared minus 8x plus 16 equals to 400. So 2x squared minus 8x plus 16 minus 400 equals to 0. So 16 minus 400 is minus 384. So 2x squared minus 8x minus 384 equals to 0. If I divide through by 2, I get x squared minus 4x minus 192 equals to 0. And this will give me x equals to, by quadratic formula, 4 plus or minus square root of minus 4 squared minus 4 times 1 times minus 192 divided by 2 times 1 plus 2a is 1. X equals to 4 plus or minus square root of 16. I'll have a positive sign because we have minus 4 minus 192. So this is 768 over 2 784. Square root of 784 is 28. So x equals to 4 plus or minus 28 over 2, which means x equals to 4 plus 28 over 2, or x equals to 4 minus 28 over 2. So we have x equals to 32 over 2, which is 16, or x equals to minus 24 over 2, minus 12. This one we ignore because we don't expect distance to be negative. So therefore, the pole should be erected from P and Q such that the distance from P to the pole is 16 meters. Distance from pole to P is 16 meters, and distance from pole to Q is 12 meters. So that's how we have to solve that problem.